record. Okay, it's recording. So this is recording not my Zoom call, but what is on this paper in my voice. That's what it's recording. Like when you guys watched the video yesterday. Hold on. Now I gotta find you guys. It's such a it's cool to have these two screens, but it's kind of pain in the butt to get it all together. Share screen, share screen. There we go. Alright. Stupid sticky note didn't work. Alright. So, losers. X squared over x minus 1 is less than or equal to 0. Okay. So the big thing in 1050, when people check the final, so bad. They're like, oh, as soon as they clear fractions, it's 0 points. It's so easy to check that problem because they get no credit and you keep it moving. So we need to talk about that. Like, why can't we clear fractions and all that good stuff? So this is the official notes for today. This is technically 1.8 continued because that video I put up was 1.8 started. So 1.8 continued, non-linear inequalities. These are a pain. So again, this is still review from 1050, but I want to try to not go super fast, but make sure you, like, this is not going away. It's going to be throughout your whole career, your math career, this process. Okay, so I want to make sure we're good with it. Alright. So, we had this guy. I just wrote down the problem again. Okay. Alright. I'm not going to do this guy, but I just want to talk about it because I want to start off with other inequalities first. But I want you to understand what nonlinear means. So for us, nonlinear, no, first of all, nonlinear means a lot of things. Anything that's not like y equals mx plus b form. That's every other function. Okay, and I know this isn't a function, but we'll talk about that in a minute. Okay. For us, as far as inequality goes, so nonlinear in terms of inequalities, okay, less than or greater than symbols. Two cases. These are what you're looking for if you want to know if something's nonlinear. Exponents or x's in denominator. Or both, like our example. Okay, so nonlinear, you got to know if you're dealing with a nonlinear situation. You either have exponents or an x in the denominator, or you got both, unfortunately. Okay. So that's what makes it nonlinear, okay, in terms of an inequality. In terms of equations, we don't care about that. If this was an equation, my lovely people, you clear fractions, multiply both sides by x minus 1, okay? You got to x squared, factor it. Like, equations are no big deal. It's the inequalities that are a pain. So you got to know what you're even looking for to start, okay? So you got to know what nonlinear means. As soon as you have a nonlinear inequality, okay, and again, you got to know if you have it or not. This is where your mind must go. You got to do a sign chart. Okay? Now, I don't know if you learned. There's technically another way you can solve these. I don't know what you learned, but this is how I'm going to do it. If you learned it a different way, you can talk to me later and show me, and I'll tell you just have to show me all that work. Because I got to see what you're doing in that other way, and the other way is okay. But this is how I'm going to teach it. You got to do a sign chart, which is a pain. Sign charts are not going away. We're going to do sign charts throughout the whole class. When you get to calculus, you're going to do 2, 3 sign charts for one problem. Okay? This is like huge. When I teach 1800 in my ESP program that you're going to get sick of hearing about, but I don't care, it's amazing. In my workshop, especially in 1050, even in 1800, stop it right now, because you're supposed to learn this in 1050. In 1800, I literally in the workshop will do a lesson on sign charts. Even though their teacher taught it, it's hard. Okay, it's just hard. So I had mentioned this in like first announcement, like you got to know what a sign chart is. So I literally am like I'm recording. I think about what I'm saying. It's okay. My title of my lesson is what the F, or when the F do I do a sign chart? Because people don't know. Okay, you got to know. So a sign chart, nonlinear inequality. Okay, that's when a sign chart happens. If you don't have a nonlinear inequality, You shouldn't be doing a sign chart. Okay? So it's like, okay, well, why? It's like, why, Sam? Why? Okay? So if you had x squared, guys, or you had an x in the denominator, okay, it's because of this. And then we're going to do an example. Okay? Cannot factor. So people here try to factor, like factor out an x, right? It's not an equation. It's an inequality. You cannot factor 0, right? That was it. Monday, factor 0, get it equal to 0, factor, and go. Factor 0 is with equations. That's not an equation, okay? So cannot factor 0. So a times b equals 0, like that's the fact we use, a equals 0 or b equals 0, only works with equations. That's my shorthand for equations, FYI, okay? You cannot factor 0 with an inequality. So, no factoring. Not yet. Alright, why can't we solve this like normal? What if we have an x in the denominator? Okay, cannot clear fractions. So these are the two mistakes people make. Cannot clear fractions. Like we did on Monday. Oh, multiply both sides by the LCD. No, you cannot do that. Because, and there's other deeper meanings to this, but this is the easiest way to remember why not. Okay, because when you multiply both sides of an inequality by something, what do you have to be careful of? Multiply or divide an inequality by something, what do you have to be careful of? What about an example what we just did? When we multiply and divided by what? What do we have to do? What do we have to be careful of? In any inequality, when you multiply a negative, changing the sign, or flipping the symbol, right? So if you multiply or divide an inequality by a negative, you have to flip this sign. It has to go to a greater than symbol. So cannot clear fractions, because how do you know if you have to clear this or flip the sign or not? You don't know.
Isn't it, if you have divide by a negative or multiply by a negative?
It's divide or multiply by a negative. So if you multiply by this x minus 5, do you know if this number down here is a positive or negative? No, because you don't know what x is. If it's 6 or bigger, then it's positive. If it's 5 or small, it's smaller than 5. I said that wrong. I said 6 or bigger. If it's bigger than 5, it's positive. If it's smaller than 5, it's negative. If it's 5, it's what?
Doesn't work.
It doesn't work. So you see all this craziness? You don't know what's going on down there. So you cannot clear fractions in an inequality because you don't know if you're supposed to flip the sign or not. All these different crazy things happen when it's bigger than 5 or less than 5 or equal to 5. Okay? So that's when the sign chart comes in. I don't know if you guys, I don't know how good my speaker is, but if you ever hear my stomach doing weird stuff, it does that. Like, just FYI. Okay? So maybe you'll hear it in the video. So because we can't do these two normal things that we do in equations, we have to do a sign chart. Okay, so our sign chart is going to help us determine what these solutions are. Okay, so I know you should have known that already, but I had to remind you of that because people jack that up all the time. Okay, so let me give you a little bit more information and make sure we're good to go. Okay, especially if you don't remember, if you learned it wrong, or not wrong, differently, or whatever. Or you didn't pay attention to 1050, whatever. A sign chart is a special number line. So notice that we did number lines in the beginning of class with those two examples and we shaded. Those are number lines too. Those are normal number lines. Sign chart is a special number line. That's when it's got like positives and negatives and bad numbers and all that stuff. So this number line is going to be real fancy. Okay. So a sign chart is a special number line used when we need to compare to the number 0. So i.e., so comparing to the number means, when you're comparing to the number 0, that means it's positive or negative, right? Positive or negative. Or what's numbers not positive or negative? 0 is not positive, negative, or 0. Okay. So if you're comparing to positive or negative, or compared to 0, greater than 0 is positive, less than 0 is negative. So when we talk about signs, that's what we're talking about, positives or negatives. So the sign chart shows us that, okay? Or it's when it's 0. And shows us when the output is undefined. So I'm kind of condensing all this. This is all the stuff you were supposed to learn in 1050. Look for my paper. So it's a lot of information. It's a fancy number line with a lot of information. Okay, so because when we get onto Monday's lesson, we're going to have regular normal lines, number lines, and sign charts in one problem. And you got to know the difference between them all. Okay? Alright. One more thing. The number line represents the x values. Okay, so on that number line that you're shading or open circle or whatever you're doing, those are the x values. So people get that confused. The number line represents the x values with the signs of the y values above. So inputs, outputs, if we talk in terms of functions. Okay. Alright, so that was my longer version of what I should have done of an explanation of a number line, or a sign chart. But it's not going away, so I need to make sure you guys are cool. Alright, so now let's do an example, okay? Solve times it. The directions are saying solve. Okay, so we're still not dealing with functions, and I know people frame it in functions, and we'll talk about that. Solve means to, just a reminder, find all values that make a true statement. Just reminding you what it means to solve something, whether it's an equation or inequality. So here's A. X squared minus x minus 6 is less than or equal to 0. That is an inequality. So I would tell my 1800 guys, my 1050 guys, and when I would tutor some of my students that ended up in calculus and they came back to me for help, and I wanted to smack them because for 2 semesters they didn't listen to me. Every time you see this symbol in your life, okay, think of it as like corona. Like, you look at it and it just like, you're just like, oh my god, like either you're terrified of it or you're so sick of hearing about it, it just irks your soul. So every time you see an inequality symbol, you're just so irritated. Either you need to just be like on alert. Like, you need to stop. Like, you could just pause. Like, as soon as you see a less than or greater than symbol, like, son of a, just mad, okay? Because you need to figure out if you need a sign chart or not. Because people forget that you need sign charts, okay? So, it's like, do I need a sign chart? Like, oh my god. Well, the only way to know is it linear? Is this stuff, this inequality, x squared minus x minus 6, linear or not?
No.
No, why not?
Because it has x squared.
You got x squared, you got exponents. So, you are not factoring this. You have to do a sign chart. Okay? So, I will show you 2 different ways you can think about it. Okay? It's up to you. But you need to know that you need to do a sign chart for this. Okay? So first, make sure it's set to 0. Sometimes they're not going to be. Now, notice I don't say set equal, because it's not an equation. Just set to 0. All right, because you're comparing to 0. This is a situation where we are comparing to the number 0. And in this case, we're comparing, we want it less than or equal to 0, we want negatives. So what this is saying, what this problem is saying is, I need all the x values that make this whole thing less than or equal to 0. It needs to be a true statement. What x values turn this into negative, and then it's a true statement. Okay, so I want the x's that turn this whole thing into negatives. Is everybody cool with that? Okay. Some people, so what I do is I determine, all right, what am I performing this sign chart on? Okay, it's the stuff on the left. Okay, that's the stuff that we need to be less than or equal to 0. I call that stuff crap. Okay, my crap that I need to be less than or equal to 0 is everything on the left. Your information comes from your crap. Okay, that's the stuff on the left. Everything that you do for your sign chart comes from your crap. Okay, people always lose it. They always screw it up. Some teachers have called the crap. I call it crap. There's a reason I don't call it a function. A function. They name it like, name it g of x equals x squared minus x minus 6. Because then you start to talk about in terms of functions like undefined, like somebody had mentioned earlier. I don't mind. However you want to label the stuff you're getting your sign chart from, all your information from, is fine. I stopped using the function notation just because 2 reasons. One, we're going to get into functions today, but more into next week. And then you're going to have 2 functions you're looking at because you named one a function, and then people get confused. And then in calc you have even more functions, so then I just stopped. I was like, no, I'm not doing functions. So I call it crap. Okay, so it's a little unofficial. That's the stuff you are getting all your information from. Okay. Alright, so zeros and bad numbers. Some of your teachers, if you had rushed, called them undefined. Okay. You need to know, so if you're drawing a number line, it's like, how do you know what numbers to put on the number line? So, to build that number line and to construct it, we start with zeros and bad numbers. Zeros are really special because that's when it makes the crap equal to 0. Undefineds or bads are important because that's the numbers we're not allowed to plug in. Okay, so everything comes from your crap. So if you look at your crap, you set your crap equal to 0 and solve. So you're trying to find the x values that make x equal 0. Or, sorry, crap equal 0. Okay, when I plug in these x's, that's what makes this left side equal 0. Okay, so x squared minus x minus 6 equals 0. You set all of your crap equal to 0. Now what do?
And factor?
Now we can factor. Why?
It's an equation.
It's an equation. Okay. And sweet Jesus, when I was checking my 1800 final exam this semester, I love my students dearly, but I wanted to smack the crap out of them. Whether it was laziness or not understanding the math, you have an equation. So when you go and factor this, make sure I did that right. These are equal signs. Okay. They were being lazy and they didn't want to write all this out, and they had inequality symbols like less than here, greater than here, or whatever they had. That is mathematically incorrect. That's not how you do it. First of all, this is an equation. The definition of zeros is when it is equal to 0. That's the definition. It's your x-intercepts. So you should not have less than and greater than symbols. So please do the right mathematics. I don't understand whether they were just totally doing it wrong or just being lazy, whatever. I'm going to start taking points off stuff. Okay? Equations or definition of zeros is when it's equal to 0. So have the right symbols. So these are the x values. If you plug them in, they're equal to 0. Okay? Alright. Bad numbers. That's when the crap has a denominator. Has an x in denominator. Does your crap have x in denominator? Look at your crap. No. Okay? So there you can plug anything you want into here and nothing's undefined. You're fine. Okay? So none. Okay. So that's how you start your sign chart. This is how you build it. Alright, so now that we have our bases for our sign chart, we can, I feel like I keep only grabbing one sheet of blank paper. we can start building our sign chart. All right, I'm gonna color code this. So here's my sign chart, and I always label my sign chart. This is my sign chart for my crap, and my crap is x squared minus x minus 6. Label it. First of all, in calculus, you're going to do a bunch of sign charts, and you're going to have to keep them labeled. Secondly, I want you to label it because I want you to know where you plug in your numbers at. Everything comes from your crap. People plug in stuff everywhere. When we get into Monday's lesson, you're not going to know where the hell to plug it at. So, label your sign chart. Your sign chart was based on this crap. Okay? All right, so remember, go ahead.
You don't have any bad numbers because there wasn't a denominator?
Yep.
Okay.
So my x values, my zeros are -2, make sure your number line's right, and 3. And I'm just going to color coordinate this. This is my y values, my outputs. Okay. And when you plug in -2 for x, this is what this means. You get out 0 for y. When you plug in 3 for x, you get out 0 for y. So this, your x number line, that's your x values, it's the numbers you're plugging in. And what comes out are the signs or the zeros or the undefined. Okay. So this special number line has a lot more information than a regular number line. Oops. All right. So now you got to check your intervals. Okay. So we need to find out.
Can you move that up, please?
Yep. What signs? I want a second. We need to find out what signs come out from each interval. So, plug in one number from each interval into the crap. People don't know where to plug it in. It's always the crap. It's always whatever was set to 0. It's just that piece. That's it. You're going to see why I'm stressing this so bad on Monday. Okay? Into the crap. Okay? Just a little FYI as we go into deeper in these. Your crap, x squared minus x minus 6, is also x minus 3 and x plus 2. That's the factored version of your crap. That's the same thing. You can use either version. Just giving you a little bit of help. Okay? You're going to see factored versions real nice. Okay? Alright, so we pick x's from each interval. So give me an x over here. X equals what? What's something smaller than -2?
-3.
-3, of course. What's something in between -2 and 3?
1.
Stop it, 0.
0.
1's fine, 0 is just easy. Okay. And what's something bigger than 3?
4.
Okay, 75. Alright, you see I like 75 a lot. You're going to see why I like 75 a lot. Whatever you want, doesn't matter. So let's go and plug these in. So this is the work you should be showing in your homework, test, quiz, all this good stuff. So when x equals -3, x equals 0, and x equals 75. Okay. You plug it into your crap. Either version. It doesn't matter. I'm going to plug it into... Oh, that should be a 2. What's up?
Should be a 2, right?
Yes,
Yeah,
good
so-
job. Good job. I just caught it. See, if I had a dry erase board, it'd be alright. Alright. Here we go. I'm going to plug it into my factored version. -3 minus 3 times -3 plus 2. That's a negative, so all I'm doing is looking for signs. I don't care about the number. I need to know the signs. This is a sign chart. So that's negative times a negative. That's why factored version is nice. And that is positive. That's all I need. Okay? I just need the sign. Plug in 0. 0 minus 3 times 0 plus 2. That's, look, I don't even care about the number. It's negative times a positive. That's a negative. Okay? And we're going to talk about putting them on the sign chart in a minute. I'm just doing these quickly. And then 75. 75 minus 3 times 75 plus 2. So why did I pick 75? Because 75 is so big, it's going to be so obvious that it's positive. Like 75 wins. 75 wins. It's like positive times positive. I don't care what you plug in. It's just easy to think about. When the numbers are so huge, you see who's winning. Okay? Positive. Okay? So when you plug in these x's, these are your y values. Okay? So we're going to put these y values on our sign chart. Alright, if you plug in, so we picked something less than -2, if you plug in any number smaller than -2, it will always give you a positive y value. Okay? If you plug in any number in between -2 and 3, you will always get a negative output. And if you plug in any number bigger than 3, you'll always get a positive. Okay? Just so you know, I'm going to do like, I don't want you to get confused with that. These are the main numbers on your sign chart, not these numbers. Those are just numbers we picked. Okay? So these are the numbers on your sign chart. These are the numbers that you're going to deal with your interval notation. So that's why I kind of just like scribble them out. Okay? I just want you to know where these guys came from. So there's our sign chart. Okay? So our sign chart represents all the x values that show our outputs to be positive, negative, 0, or undefined. Okay, that's a complete sign chart. All right, let's go back to the original problem, which was x squared minus x minus 6 is something. Where's my notes? Less than or equal to 0. Okay. So, less than or equal to 0 means negative or 0. So we want the x's that make the left side negative or 0, because that will make a true statement. So all this work was to solve this inequality, was to find the x values that make a true statement. All that is annoying. Okay. So you look at your sign chart and you're like, all right, what x values make this a true statement? Make all this stuff, this whole left side, my outputs, less than or equal to 0. So which one of these sets of numbers do you get negative outputs or 0 outputs?
-2, 3.
Yep. So included, because that equal sign, right? And then if you plug in these x values, I wanted to do orange, son of a biscuit. If you plug in these x values, they will give you a true statement. Okay? That's what that means. You plug in the x values, they give you a true statement. So your answer in interval notation is -2 to 3, included because of that equal sign. Okay? That's how you solve that inequality. You don't clear fractions, you don't factor, you do a stupid sign chart. Annoying sign chart.
What are you talking about?
Say it again?
What equal sign are you talking about?
Right here. This guy right here.
Oh. Okay.
Yeah, so that's what makes it included. So include zeros because of equal sign. So they're not always included.
Okay, so I can now see why I was getting confused, because I knew how to do back to absolute value. So I remember how we were like doing the chart, and I was like putting positive and negatives, and I was saying like, oh, what was that? Like, but it wasn't what you were doing.
Oh,
so is there a way, where I can't like confuse them both?
That's a great question. The only thing I could say is absolute values are just in their own world. Like, you should not be doing sign charts with absolute value inequalities. They work differently because the definition of an absolute value, that's why we keep them separate. So that was like when I started class, these are the 3 categories for inequalities: linear, absolute value, nonlinear. Those are the 3 things you keep separate. Technically, so you do a sign chart here. So look, I'm gonna write this. Sign chart, okay, and/or, and then normal. Get x by itself. So that's how you solve these guys. Sign chart, this is the and/or thing, or no solution, all reals. And then this is just get x by itself. Technically, if you do a sign chart for a linear guy, it'll work. You're just doing too much work. You will never get it wrong, though, if you do the sign chart right. But this absolute value, we just treat those completely different. That they're in their own little world. That's why we keep them separate from nonlinear. So it's the absolute value part that makes it weird. So yeah, those get confusing.
If that sign said not less than but greater than, then we would be doing the plus sign.
Good. Yes. Yep. So if you had a brain fart or wrote the problem wrong or something, you did all the work, you would have grabbed those 2 intervals. Yep.
Okay.
Yep. Any other questions, clarifications about that guy? Okay. So I know I'm taking a lot of time on this, and I probably shouldn't, but I already know. Somebody's going to screw it up. I promise you I should bet money on it and quit my job and win the lottery. Somebody's going to screw it up next week, I promise. So listen to what I say. Okay? Alright, that was only A. Stop it right now. There's B. Where's my... I gotta figure out how to get organized. I'm not used to this like that. I got notes, and then I got paper. Like, I miss my board, guys. Alright. You want to hear something funny? I'm gonna tell you the tales of my mother as the summer. She tried to tell me this morning. She was like, "Oh look, it's like you're growing a mullet." Really, really. I need a haircut. I was so irritated. She was like, "It's cute." I'm like, that's not a compliment. That's not cute. I was very upset.
Is that a B on the paper?
Yeah, that's a B. Are you talking junk about my handwriting?
No, like just on my screen, it's like
Is
really
that better?
blurry.
Okay, is that better?
No, on my screen, I don't know why, just it's like really blurry. So
Really?
it's like
Is
yeah.
it blurry for anybody else? I just went through a whole lesson.
No,
Okay.
it's on my.
Okay, I just wanna make sure.
I know that my
Ooh, that's extra
Wi-Fi is
blurry.
like pretty crappy.
Ah, damn it. Sometimes when I mess with the
Mine's
autofocus,
not on my end.
well, now I messed it up. Sometimes when I do
take-
that,
It's not my fault. I take no blame.
dang it, stop it right now. Oh, I knew I shouldn't have messed with it. I don't know why, but when I auto, it's like, it's fine, and then it's not. Damn it. Let me see. I might have two